Thank you, Chris, for that introduction, and thanks to GitHub for organizing this conference. I think they're doing a wonderful job. Give it up, please, people. I'd like to talk about version control, CI, and CD. As a developer, you have many environments in which you work. You work in development, obviously. You have your tests that run in continuous integration. And you have your production environment, continuous deployment, delivery, what makes it all work. And what my thesis today is that these environments need a compatible version control workflow. First, I'm going to show that currently, even if you use the state of art, the best things that are around, you're kind of bound to use incompatible formats to define your environments in this way. So for development, suppose you're top-notch, you use a browser IDE called coding, then this is a stack file that you use to define your development environment. You specify that you want to boot up an instance on Amazon Web Services. You give it some variables. You say exactly what you want to do, what you want to install. So this is the stack file for development. Then for CI, you could use something like GitLab ci.yaml. GitLab comes with a complete CI environment, and if you add this file, it will start running your tests. At the top, you can define a Docker container that you want to use. You can also define some other services that you want to use that you need to run your test, like a database. Define caching, have scripts that provision your environment. This is how you could do a CI environment. And then to deploy to production, suppose you use Kubernetes. This is a kubernetes.yaml file. You define how many replicas of your application you want, so you have some redundancy. You define what kind of containers, where the ports are, etc. I hope you see that all these examples were really different. And I don't think that's the future. I think the future is that we'll use the same format, and that it will be easier to unite these different environments. And I think that format will be used on container images and with a container scheduler. Containers are like lightweight virtual machines. The container images define what is inside the machine, the software that's loaded on there. And a container scheduler, you can think of it as something that provisions all the different containers and that makes sure that there are enough. If your load increases, you'll get more containers. If you need to go somewhere else, it will move the containers for you, so you can take a node offline to do maintenance on it. Examples of container schedulers are Kubernetes, Apache Mesos, and Docker Swarm. And I'll try to show that what I think is the future, that we'll use these technologies in all our environments. For the development environments, and all the other ones, I think we'll base it on a Docker file. So most of you probably are aware what containers are. I think that every time you push an update to your Docker file, your version control should make a new container for you and add it to the version control registry. There's one problem. We thought about doing something where if you push a new container, you push a new Docker file, we run a CI job and add that container to your build artifacts. Build artifacts are a way to store a binary you generated. But a container is not quite like your average executable, because containers have different layers. Every time you run a command in your Docker file, it will store that as a new layers, and these layers build upon themselves. If we would just use build artifacts, we'd lose all that information. And anytime you make a small modification to your container, you'd have to upload the whole binary again. This is less than ideal and not performant. So I think that the future is that Git hosts should also be container registries. Not only do they store your source code, but they also store your containers. And this makes something interesting possible, because what you want is one Docker file for all your environments. So what you could think of, suppose I have a Docker file and it creates multiple layers. I first built a Docker file so that it is ideal for production. But for example, I used to be a Ruby programmer. And in Ruby, if you want your development environment, you want some additional gems that you have to bundle in that will end up in your container image, creating a different container image. And it's not, I can't leave those gems out for development, but I don't want them included in production because they might cause things to break. What you could do in your Docker file is first make it provisioned for production. So that's the third layer here, the CD layer. I first make a Docker image that's ready for production. Then in the additional lines of the Docker file, I specify something that's fit for testing, CI. And then in the last few lines of the Docker file, I again rebundle, add new gems, and make it compatible for development. This way I can have one container image for my project, but for my production environment, I deploy the third layer, and for my development environment, I deploy my fifth layer. So the idea is that not only would your environments work with container images, they should also work with a container scheduler. And I want to describe how that would look for dev, CI, and CD. For dev, it doesn't make sense to run a complete like Kubernetes instance on your MacBook. Will probably not be very performant. So the people from Registries make something called local kube that you can run locally, but that's API compatible. And for Mesos, there's mini Mesos, which, as far as I understand, does quite the same thing. For your CI environment, you want a container scheduler that goes up and down with your workload. Right now, container schedulers can provision more and less containers, but what they can do is have more or less instances. So they cannot request an extra virtual machine for you. And what we saw at GitLab, testing our own stuff, is that our load varies dramatically. Normally, it are just a few containers that are running, but sometimes it peaks to over 100 instances. So we created something called GitLab Runner Autoscale that uses Docker machine as a driver to automatically provision wherever you want more containers. You can use it with OpenStack. We use it with DigitalOcean to automatically request more virtual machines as our load increases. And then when the testing is done, they're automatically deprecated. This has worked very well for us, so I'm happy to announce here on stage today, a few hours ago, we enabled this for GitLab.com. And right now, if you want to run your tests on GitLab.com, you get free CI with free auto provisioning of your containers. And we think this is a great way to make sure that your demand is met and you're not paying more than necessary. Lastly, with continuous delivery. On our most recent GitLab version, we had something that's called deploy to Kubernetes. It again uses the Registries things, and it allows you to go directly from GitLab to Kubernetes without any scripts. So we want to get rid of all those deploy scripts that are brittle and sometimes break, and replace them with something where your versioning is aware of your production environment. One interesting thought is that we have the concept of branches in Git. Wouldn't it be nice to automatically A/B test every branch? So instead of having a merge button, I'd have a button that says merge if better. And it gets automatically tested, A/B tested, and only then deployed. I hope I showed that there's a way to have a workflow that uses versioning to have more compatibility between development, CI, and CD. And I look forward to talking with you later tonight and maybe at the party we sponsor about these ideas. Thank you.